Welcome to session 1 of module 16 on blockchain for a smarter energy market. In this session, we'll talk about what blockchain is in a very basic way and why this technology has the potential to disrupt businesses across the globe, including energy sector. Businesses normally thrive in a network, right? So we'll have multiple players in a business network. Now, these are participants with some identity, right? And what happens over a business is assets flow in some form, be it a service or a product. And these assets are described as transactions, right? Which is primarily an asset exchange. Now, for all these transactions to happen, there is something called as a contract which underpins all these transactions, which governs all these transactions. A ledger has been used to log all these transactions for centuries altogether now. Now, before blockchain actually came in, the traditional approach of doing business is, given in this snapshot. Consider a business network with some 6 participants, participant A, B, C, maybe a bank or a regulator or a insurer as a part of the blockchain network. Now, at any point in time, all these participants will be exchanging some form of documents with each other. It can be electronic format of documents or a paper format of documents. It can be anything. Now, what will actually happen at any point in time X, for each participant, the transaction will be in a different state because each participant has its own system of records in silos in isolation. So that's what is ledgers, which is native to the organization, to their particular organization. Now, what will happen is, unless the transaction gets consolidated across all the business network participants, which takes a longer course of time in a traditional business environment, the system is actually in a disparate state, which leads to an inefficient and expensive and a vulnerable system, right? Which leads to a lot of conflict in the business partner network. What we are proposing here is a blockchain-based solution which provides for a shared, replicated, permission ledger, right? Now, again, we have a similar scenario in which we have 6 business participants. The only thing here is we do not have a siloed approach of visibility for each of the participant. Here, each participant on the network has one single shared ledger which is shared across the network. Each participant has the same copy of the ledger. Now, having said that, we need to understand that we are talking about private permissioned blockchains here. We're not talking about public anonymous blockchains from a business point of view. So we're talking about permissioned ledgers here, right? So the business partners know each other. It's just that the way of doing business, they have adopted blockchain as a way to do it, right? Rather than the conventional approach of doing business. Now, in this particular approach, what happens is, whenever a particular business network partner or a participant wants to write on this ledger, they needs to actually arrive at a consensus from the participating network partners, right? What it in fact leads to is a provenance and a finality of the ledger. And of course, since we are talking about a blockchain-based solution, so the ledger is immutable, right? So we'll discuss more of this in due course of time as well, right? Now let's try and understand how is blockchain-based solution different to a traditional databases, and how traditional databases cannot be used in untrusted networks, because that is where blockchain stands out, right? Now, in a traditional database, it's centralized, right? Wherein everybody needs to trust the administrator of the database, right? And there is no concept of a immutability or a provenance, because whenever you write to a database, you can rewrite the database again. You can rewrite on top of it. You can make editing on top of it. Let's talk about distributed database as well, which do not again elevate the trust issue, right? And in this particular case, what will happen is, since there are multiple copies in the network, so there will be much more number of administrators managing all these copies, and hence again more the concern of trust or immutability or the provenance, right? What blockchain provides is for a concept of distributed database to be deployed across an untrusted network. Now, when we say untrusted network, we basically assume that the business network participants are getting into a network and they are, sort of getting into a business agreement to do something. And and of course, we're talking about the basic tenets of a blockchain-based system, which is primarily around consensus, provenance, immutability, and finality, which makes a blockchain solution stand apart compared to a traditional database. Let's try and understand what are the typical requirements for a blockchain, for a blockchain solution for business, right? So one, we're talking about a shared ledger here. Now, though the ledger is shared, we actually can decide what can be, which participant can actually see what, right? So we'll see that as a part of the confidentiality here. Second is the identity. The network, in a network, people need to know, whom they are dealing with, who is the party that you're doing a transaction with. So participants need to know the identity of the business network partners. Third and most important is the participants need to have a provable endorsement, right? So that in a business network, there is no conflict at a later point in time out of some certain transaction which has happened. And of course, the confidentiality. So since the ledger is shared across the network and it's the same copy of the ledger, you need to have some mechanism of constraining the information that needs to be shared, right? So that's where the encryption part comes into play. So in a given network where A, B, C, D may have the same copy of the ledger, A only gets to see what it is supposed to be seeing, right? That is basically controlled by, we call as encryption here, right? So these are the typical requirements of in a business for a blockchain, right? Now, let's try and understand more about what all these four things are. Now, assets are something which basically derive value, right? And they can be digitally represented on a blockchain. Now, transactions are basically the change of state of a particular asset, right? For example, you transferred an ownership of a particular real estate, so that means there is a transaction happening. You transferred the digital, music that you would have bought, and you transferred it to somebody else. So that's again an asset which is being transferred. This is basically a transaction happening, and these transactions are governed by something called as smart contracts, which are verifiable business rules that causes the status of an asset to be changed, right? So that's what is a ledger all about in a blockchain network. Second is, in a business, identity is very key, right? You need to know whom you are dealing with, and that's the reason we have all these KYCs and all these to understand the identity of a person in a business network. Now, there are so many regulations which are applied to businesses in order to understand the identity of a person we are dealing with. And of course, there is a lot of regulations and which are governance, which are sort of implemented along with that. Now, there are several mechanisms to establish the identity of a person. Now, cryptography is central to all of this. And these transactions, since they have to be signed and encrypted, therefore identity plays a very important role in a blockchain-based network. Coming on to the transaction endorsement, right? It's basically a process where you verify a certain transaction, whether it's good to go or not, right? In a blockchain based business network, it is particularly important to prevent a double spend, a case of double spend, as we say in technical terms, right? Now, if you talk about a public blockchain where people are anonymous and transactions are actually given out to the entire network, for endorsement, this can be a really costly affair. You can take a cue from the way mining happens in a Bitcoin network. Uh, Proof of work is particularly, very CPU intensive, very energy intensive. Since we're talking about permissioned private blockchains here, here the concept of endorsement is entirely different, where we have a couple of algorithms, some mechanism to do this endorsement there. Uh, so therefore, in a real world, these transactions are basically endorsed by a smaller number of participants, which have a real stake in the transaction, right? And the key is this transaction needs to be completed in a certain delta x time, in a certain fixed time frame, so that there is no probability of double spend any further in that. Coming to the fourth important point, which is privacy and confidentiality in a particular blockchain system. The transaction visibility is something which everybody needs to know, because that's where the transparency comes from, right? And since we are talking about, I'm again and again emphasizing that we are talking about a private permission blockchain. That means we have the scope of business network is restricted to a few participants there, which are known to each other. And individual transactions are normally confidential, right? And therefore, we need to protect them in a certain way using encryption mechanism that it's not made available to everybody. One more thing, important thing to note here is transparency for regulation is very critical, right? And at the same time, it's very important to have a constrained visibility across the participants in a business network, because on a business network you can have business competitors as well collaborating, and if that information is made available to every participant in the network, it may give an unfair advantage to the other participants. um, so with this, we'll end the module, this particular session, and we'll talk about how we can make, how to understand more of blockchains, what are the use cases, what are the implementations in next session. Thank you.